Hi friends, this is Rishi and welcome to Science with Rishi. Today in this video we are going to start the chapter number 3 and the name of that chapter is Motion in a Straight Line. Okay, so shall we start? As the name suggests, in this chapter you are going to deal with different cases when an object is moving in a straight line. Okay, so before anything, let's discuss when do you say an object is in motion. It is whenever the position of that object is changing with respect to time and with respect to certain point which you have chosen arbitrarily. Okay, let's take an example. Suppose you have a road. Okay, suppose this is your road and you have a small car here. Okay, if this car is moving with respect to some tree here, okay, suppose this is a tree, and if this car is moving to some direction, either to the left or right of the tree, you will say that the position of this car is changing with respect to this tree, right? So we can say that this car is in motion, and here this tree is your reference point, and this is in the case of one dimension. Okay, that actually the car is moving only in one direction. Let's take the next example where you have a board or you have the wall of your room. There is a small insect sitting on it and it is crawling on the wall. Okay, so here in this case it is moving in two dimensions, in your x and y, right? So here the intersection point of this x and y axis, this x and y axis, and actually that insect is moving, right? So you have to take the reference point as the intersection of this x and y axis, and here we can say that the position of that insect is changing with respect to this reference point, let it be O. Now when it comes to 3D, where you have a flying inside your room, you have to take all the three axes, right? So here the intersection of all the three x, y and z axis, x, y and z axis, this will be the origin, and here also the position of that insect is changing with respect to time and with respect to this reference point. And now imagine the first case. Here with respect to this tree the car is moving, right? But what is the position of the driver with respect to another passenger inside the car? With respect to that driver, that passenger is at rest, right? Because both are moving at the same velocity or at the same speed. So with respect to this guy is at rest. So that is why we are saying we describe an object is at motion whenever its position is changing according to the reference and according to the time. Both are important. Okay. Now, what is path length and what is displacement? Okay, path length is simply the distance traveled by the object within a given time. Okay, it is simply the distance traveled. And displacement is the change in the position of that object within that same time. Okay, it is the change in the position. To understand it fully, let's take the example that has been given in your textbook. Let's take different cases. Case 1, actually the object, let it be a car, okay, our car was at origin and it went in a straight line up to point P, which is at a distance of 360 meters from origin. Okay, so from O to P. So what is the path length? It is 360 meters. And what is the displacement? Displacement is also 360 meters, right? This is a difference in the position of our object within that time. Okay, here the displacement is also 360 meters. Now in the second case, the car is at O, it went to P and it came back to Q. Okay, so O to P to Q. So what is the path length? It is 360 plus another 120. So 360 plus 120, which is 480. Okay. Now here, what is the displacement? Now our car is at Q, which is at 240 meters from origin. So what is the difference between the positions? It is only this 240, right? So here the displacement is 240 meters. Now take the third case. It went to P and it came back to O. So O to P to O. So what is the total distance? 720 meters, 360 and another 360 back. But what is the displacement? There is no change in the position, right? Displacement is 0 meters. And let's take, it is going from O to P to O to R. R is at 120 meters to the other side. Okay, that is the most important thing, to the other side. So here we are taking this to be the positive and here we are taking this to be the negative. But path length, it is simply the sum of the distance traveled. So another 120 will be added, by which it will come to 840 meters. But here the displacement will be minus 120 meters. Okay. Now here certain points that you have to note is, see, the path length and displacement, they can be same in magnitude, okay, but displacement will not be greater than path length. Okay, here you can see the path length is going on increasing and the displacement is changing according to the position. You cannot have a case where the displacement is greater than the path length. Okay, the displacement can be 0, but path length, once the object has started moving, that will never come back to 0. Common sense, right? And the third one, displacement is a vector quantity. It has got some direction, because what is displacement showing you? It is a difference in the position of the object between a time, right? So it is showing you that yes, the object is at this point towards this direction. Okay, so displacement is a vector quantity, but path length, it is simply the sum of all the distance that object has traveled. That is simply a scalar quantity. Okay, these 3 points you have to keep in your mind when it comes to the difference between path length and displacement. Now let's study the difference between average speed and average velocity. Okay, average speed is simply the total distance divided by total time. Okay, simply the total distance or the path length divided by time. while average velocity, it is the change in the position or the displacement divided by the time taken for that displacement. Okay, let's study it little bit detail with the example 3.1. Now in the example 3.1, they are saying that a car which was at O reached P, which is at a distance of 360 meters from O, in 18 seconds, and it came back to Q, which means 120 meters back, in another 6 seconds. Now let's study what is the average speed and average velocity here. Average speed in the first case from O to P, it has traveled a distance of 360 meters in 18 seconds, which means this is 20. Okay, now here the average velocity is also 360 divided by 18, which is 20. Okay, now in the second case, it has come back to Q. Okay, so the total distance between 480 and the time became 480 divided by 18 plus 6, which is giving you another 20. But here, what is the average velocity? The displacement came to 240 divided by the total time is 18 plus 6, which means it became 10. All these are meter per second, okay? Okay, so hope you have understood what is the difference between the average speed and average velocity. In the average velocity, we are considering the displacement. Okay, now just understand, if you are taking the case between P and Q, okay, only between P and Q, here the displacement is 240 minus 360. Okay, if it is between P and Q, the displacement is 240 minus 360, which is minus 120 meters. And what will be the average velocity? It is minus 120 divided by 6, which is minus 20 meter per second. Which means, just like displacement, average velocity is also a vector quantity, while average speed is always a scalar quantity. And you cannot have this average velocity greater than average speed. Just like displacement cannot be greater than the path length, average velocity also cannot be greater than average speed. Okay, that's it for the video. We will continue with the next topics in the next videos. So until then, Rishi signing off. Bye. Take care. Jai Hind.